Okay, I have to start this one with a number that genuinely made my jaw drop.
All right, hit me with it.
$792.
Wow.
And that's the sale price. It was marked down from almost $1,000 for a single cable.
A single cable. Yeah, that's some serious sticker shock.
But we have to, immediately switch context here. We're not talking about the 6-foot cord you grab at the store. This is a 90-meter cable that's, nearly 300 feet long?
It's practically the length of a football field.
Tight.
But even so, for that price, something completely different has to be happening inside that little black tube.
Exactly. So that's our mission for this deep dive, right?
Yeah.
To unpack the tech inside this active optical cable and figure out why just moving data has become such an expensive physics problem.
And it is a physics problem.
It absolutely is.
Yeah.
When you look at the specs on this Kramer cable, the first thing that just jumps out is the sheer amount of data it's pushing. We're talking 8K resolution.
It's 60 hertz.
At 60 hertz.
Sick.
To do that, you need a data rate of 32.4 gigabits per second, which is just massive. And that's where regular copper wire just, it gives up, doesn't it? After a few meters, that signal completely disintegrates.
It does. It's like trying to shout across a canyon. The electrical resistance is just too high. So to get that pristine 8K signal across almost 300 feet, they had to cheat.
How so?
They used what they call a hybrid construction. Inside the jacket, you've got 4 strands of multi-mode optical fiber doing the heavy lifting, running right alongside 8 copper wires.
Okay, see, this is what I found really interesting. I get switching to fiber optics. You're using light, not electricity, so there's like zero resistance over distance. But if fiber is so much better, why keep the copper at all? Why not just go 100% fiber?
It's all about making sure everything works smoothly. So the fiber handles the massive video data stream, but the copper wires, they're there for the low bandwidth chatter.
The handshake between devices.
Exactly. Things like EDID and HDCP, which is basically your source device asking your screen, hey, what are you? Copper is just more robust for those little signals, making sure the devices talk to each other before the video starts.
That makes a lot of sense. So let's talk about the active part of the name.
Yeah.
Usually when I see active cable, I just cringe.
Yeah.
I picture this bulky box halfway down the line that needs its own wall outlet, and it's a nightmare to hide.
Oh, wall wart. Yeah.
Yeah.
Another thing to plug in. But this is completely different. The active part, the electronics that convert electricity to light and back again, it's all inside the connector heads.
Okay.
And here's the kicker. It requires no external power supply.
Wait, really? How does it just pulls power from the DisplayPort connector itself?
It just sips it. The spec sheet says it draws less than half a watt.
That is wildly efficient. I have USB drives that run hotter than that.
It's an incredible bit of engineering. And since it's so efficient, they didn't need big heat sinks or anything, which leads right to the physical build. You'd think it would be bulky, right?
Yeah, you'd expect a thick, heavy cable.
It's only 4.8 millimeters thick.
That's thinner than some of my old HDMI cables. But it's also supposed to be rugged. They're claiming a pulling strength of over 25 kilograms.
It has to be. It's designed for installers who are pulling this stuff through ceilings, through walls, through conduit. But the real reason this costs $800, it's the safety rating.
You mean that low smoke and halogen-free jacket?
That's it, the LSHF jacket. And that is not marketing fluff.
I'll admit I kind of thought it might be.
Not at all. That is the difference between passing a building inspection and failing one. If you run a cheap, regular cable through a plenum space, like in an office ceiling, and there's a fire,
it melts and releases toxic fumes,
which gets sucked right into the HVAC system. This LSHF jacket prevents that. For a professional installing this in a hospital or an airport, they legally cannot use the cheap stuff.
So when you put it all together, I mean, I'm not buying this for my living room.
Probably not, no.
But I totally get why an airport flight board needs it. This isn't just a cable. It's a piece of professional infrastructure.
That's the perfect word for it. It's infrastructure. The pipe is becoming just as important as the screen you're plugging it into.
So we'll leave you with a final thought to mull over. If getting a single 8K signal from one end of a building to the other now requires lasers, hybrid metallurgy, and specialized chemical engineering, are we reaching a point where our physical infrastructure, not the display tech, is the real bottleneck for the next generation?
A very expensive question to answer.
Thanks for listening to this deep dive. We'll catch you on the next one.